Hello, this is a Calculus 2 video, and I'm going to solve, I think, 4 problems. So let's get to work. Alrighty, so this is Math 1440. This is our last section. This is the last new material for the semester, 12.4. And that's all we got to do for next week, 12.4. So here comes the first problem. Find the integrals. So we got this integral of a difference, and that can be solved by the difference of the integrals. So we're going to take the integral of this first term minus the integral of the second term. So we're going to use the power rule. The integral of x squared is x cubed over 3. And I know the derivative of cosine of an angle is minus sine of an angle, but the integral of the cosine of an angle is going to be plus the sine of the angle divided by the derivative of the angle, because that's the quick way of doing it. So here's what we have. Here's our solution for the first problem. The integral of x squared minus cosine 2x dx is going to be the x cubed over 3. And then it's going to, you keep that minus sign, and the derivative of the cosine of 2x is the sine of 2x divided by 2, because we're doing an antiderivative. And then don't forget the plus c. So if you don't like that shortcut, because I did the shortcut way, you can use the u substitution, u equals 2x, and you'll get the same answer. If you look at my lecture notes for this section, which I put on Learn, just about an hour ago, I did it both ways, the shortcut way and this u substitution way. Okay, so we're done with the first problem. Let's go to the second problem. Here we go. We want to find the integral of this product, the square root of cosine x. Think of that as cosine x all raised to the 1/2 power, which you could write as, cosine x all to the 1/2 power. That's the best way. Times sine x dx. There is no product rule for integration. This looks like a perfect u substitution technique because sine and cosine, they're kind of derivatives of each other. So you might think, let's let u equal sine x because the derivative would be the cosine x. But because the cosine x is raised to a power, like cosine x to the 1/2, you can think of that as, let's let u equal cosine x. And then ultimately, I'm going to have an integral of u to a power, which we know how to handle. So let's let u equal cosine x, because that's like the more complicated factor. So let's see what we have here. So here's our solution. Let u equal cosine x, and then du dx is negative sine x. And again, you can have all these rules written down before your final exam, so that way you save time. And then what I do is solve for dx. So that's what I did right here. So I did this, really, I skipped a step. So if you have du dx is negative sine x, first multiply both sides by dx to clear the fraction. And then when you multiply each side by dx, then you divide by negative sine x. So here's what you get for dx right there. Now that I have it solved for dx, we're going to rewrite this original integral with our substitutions. So instead of writing cosine x to the 1/2 power, because cosine x is u, we're just going to write the integral of u to the 1/2, and then keep the sine x because we have no substitution for that. See, we have no substitution for this. But then in place of dx, we're going to write this expression here. So there it is. Instead of dx, we wrote what dx was. Notice the sine x's cancel out. So that looks good. And now we just have, I brought out the negative sign, so this negative I brought out. So now we just have negative the integral of u to the 1/2 du. And to evaluate that integral, we just use the power rule. So 1/2 plus 1 is 3/2. And then instead of dividing by 3/2, I just multiplied by the 2/3. And again, we want to make sure you bring down that negative. And don't stop here because we want our answer in terms of x in the end. So what was u again? The cosine of x. So there's our final answer. Instead of writing negative 2/3 u to the 3/2 plus c, u is cosine x. So there's our final answer. So let me just look at that problem again so you can all see it. There was the original problem. It's clearly a u substitution problem. So we let u equal the more complicated factor, the cosine of x. And then we got our du dx, and then we solved it for dx, and then we rewrote. And there's the rewriting. And then the sine x's cancel. We brought out the negative sign, and then we did the power rule, and we switched back to x's. So there we go. So we got 2 problems done. Let's go to the third problem now. So here comes the third problem. We got the integral of tan cubed x. That's the same thing as saying tan x in parentheses cubed. This is the shortcut way of writing it. So tan cubed x times secant squared x dx. This is another product. There is no product rule for integration. So here's what I'm thinking. I know the derivative of tangent x is secant squared x dx. So why not let u equal the tangent of x? Don't involve that power of 3. Just let u equal the base, tangent of x. So let's do a u substitution I wrote. And we're going to let u equal the tangent of x because the derivative is going to pick up that secant squared factor. So du dx is secant squared x. And you can prove that by writing tangent as sine over cosine and figuring out the quotient rule. Okay, but you don't have to do that. We know what it is. So du, I multiplied each side by dx, so here I showed my work better. So du is just going to be secant squared x dx. And then the way I do it is I like to solve for dx, but you do it whatever way you like. And to solve for dx, we divide each side by secant squared x. Now that I have it solved for dx, we're going to rewrite the original integral. So again, here was the original integral. So I'm going to write this as the integral of u cubed du, because du, whoops. Okay, sorry, I'm getting ahead of myself here. So let's see what happened here. We're going to write it as u squared, that's right, we have no substitution for secant squared x. So it's u cubed rather, the integral of u cubed secant squared x times, and then in place of dx, we write what we got, which was du over secant squared x. Right now it looks like a tempest in a teapot. I see u's and x's, but the secant squared x's drop out, they cancel. So now we just simply have the integral of u cubed du. And by the power rule, that's u to the 4th over 4 plus c. Don't forget that plus c for all indefinite integrals. And then you want to replace the u back to the tangent. So u to the 4th becomes tangent to the 4th x. And then dividing by 4 is the same thing as multiplying by 1/4. So I wrote it like that. 1/4 tangent to the 4th x plus c. And again, that's the same as saying tan x in parentheses to the 4th power. So let's review that problem because we got the time here. So this was our original problem. And then we said let u equal the tangent of x. And then the derivative du dx is secant squared x. And then I solved it for dx. So when I rewrite, I'm going to write this first factor as just u cubed. We have no substitution for secant squared x, so just rewrite that. But in place of dx, we're going to write du over secant squared x, which we did right here. So that's exactly what we have. And then you can see everything else. Done with that problem. And now we go to our fourth and final problem. And again, if you see the lecture notes, you'll see a lot more problems. So this fourth problem, I have a definite integral from 0 to pi of 2 cosine x plus 3 sine x. So the first step is to find just the antiderivative. Don't worry about these limits of integration until later. So first step is find the indefinite integral of the 2 cosine x plus 3 sine x dx. And just use the sum rule for that. Just use the sum rule. The integral of the first term plus the integral of the second term. And that's what I did right here. So the integral of the first term is going to be 2 sine x, because I know the derivative of cosine is minus sine. So the integral of cosine is a positive sign. And I brought out that factor of 2. So you pull out the 2, the integral of cosine x is sine x. And I know the derivative of sine is cosine, so the integral of sine is minus cosine. So that's why we got this minus sign. And then 3 times the cosine of x. Now that I have my antiderivative, you draw the evaluation bar, and we're going from 0 to pi. Okay, you input the pi first. So wherever you see an x, you're going to write pi. So I get 2 cosine pi minus 3 cosine pi minus the expression 2 sine 0 minus 3 cosine 0. Let's just look at that again. So first we inputted the pi right there. And we get 2 sine pi minus 3 cosine pi minus parentheses, then you input the 0. 2 sine 0 minus 3 cosine 0, which we have right there. And now, the sine of pi is a number. Remember, the sine function, you input a real number, and you're going to output a real number. So what is the sine of pi? How did I know it was 0? And here's one way you can do it, by using this beautiful trig sheet, this unit circle, which is on Learn. So since my angle was pi, here's my circle. This is 0 radians, pi over 2 radians, pi radians. So at pi radians, the terminal side of the angle intersects the circle at the ordered pair -1, 0. If I want to know the sine of pi, remember the sine of an angle is equal to the y-coordinate of that point for the unit circle. So that's why the sine of pi, the angle pi, is equal to 0, which we have right over here. The sine of pi is 0. And then instead of writing minus 3 cosine pi, we've got minus 3 cosine times the -1. So why is the cosine of pi -1? Let's go back to the unit circle. And here we are. You know, the angle is pi, and the terminal side of that angle slices the circle at 1, 0, and the cosine of an angle is equal to the x-coordinate of that point that the terminal side intersects the circle at. And the x-coordinate is -1, so the cosine of pi is -1, and that's why we wrote -1. Let's see, gosh, this thing doesn't want to get clear. Gosh, what happened? Oh, there we go. Okay, so there's where we got the -1. The cosine of pi is -1. Minus, instead of writing 2 times the sine of 0, evaluate the sine of 0. When I input 0 into the sine function, what real number output do I get? So, and then also I want to figure out the cosine of 0 as well. So let's just confirm, why is the sine of 0 0, and why is the cosine of 0 1? So let's look at that unit circle again. So be sure to have this sheet for your final exam. It will save you a lot of time. So notice when you have an angle degree of 0, that means the terminal side coincides with the initial side of the angle. So the cosine of 0 is going to be the x-coordinate, 1, and the sine of 0 is going to be the y-coordinate, which is 0. So that's what we said. Just for practice, since I'm looking at this unit circle, what do you think the sine of pi over 6 would be? So you have an angle that's pi over 6. So where does that angle intersect the unit circle? It intersects the unit circle. The terminal side of that angle intersects the unit circle at this ordered pair. So what's the sine of pi over 6, which is the same thing as 30 degrees? The sine is going to be the y-coordinate, 1/2. What's the cosine of pi over 6? The x, which is square root of 3 over 2. So that was just for practice. Okay, so we're almost done now. We're running on 14 minutes right now. So to finish out this problem, you just next evaluate what does this equal. So 2 times 0 is 0, minus 3 times the -1 is the +3, and then I've got minus, and then inside the parentheses is going to be 0 minus 3, which is a -3. So this becomes 0 plus 3 plus 3, because minus and negative is a plus. So 6 is our final answer, and we're done with that problem. I'll just hold it here so you can look at it a little bit longer. There was the original problem. We integrated, we evaluated, and then we just simplified. And we are done. So we'll start reviewing pretty soon for the final exam. Remember, there is no more tests except for the final exam, which is May 11th. May 11th, 7:30 to 9:30 in the morning on WebAssign, where you should have fewer problems than you did perhaps on test 2, because no approximations pretty much. Just give exact answers so that way there's no ambiguity. All right, good night, everyone.